Good morning, everyone. Today, I would like to give a talk on activity behavior, pattern mining, and recognition. I'm going to give this talk on 5 parts. First, introduction. Second, research outline. Third, methodology. Fourth, experiments and analysis. Finally, conclusion. As human activity in mobile environments is facing with an ever-increased range of data. Therefore, a deeper understanding of the human activity behavior pattern and recognition is of important research significance. However, human activity behavior that consists of a series of complex spatial-temporal processes is hard to model. A large amount of related work has been done by previous research, such as the influence of social demographic features, trajectory, spatial temporal features, longest common subsequence problem, and the learning model. Although a large amount of work has been done in the previous studies, notably, the past studies seldom focus on both activity behavior and social demographic pattern mining and recognition. Therefore, in this paper, we make sense the following problems. For similarity computation, the method consists activity, time, location, participants, and activity sequence. Appropriate activity granularity can obtain by adjusting them flexibly. 3. Cluster analysis are visualized. 4. Pattern is recognized by activity or social demographic features. The framework of our model involves 2 modules: pattern mining modules and the pattern recognition module. The process of pattern mining and recognition comprises 4 steps. 1. Similarity matrix among individuals is calculated. 2. Clusters are organized by cluster algorithms based on the similarity matrix. 3. Representative patterns are obtained by characterizing the cluster memberships. 4. Patterns are identified by classification. Activity behavior consists of a series of activity actions. So, we calculate activity action similarity first. For 2 activity actions, K and L, the similarity is defined as the equation 1, where sim A is a function to compare activity categories. Sim T is a function to compare the time. Sim L is a function to compare location. And sim W is a function to compare the participants. For 2 individuals, DI and DJ, their daily activity behaviors are BI and BJ. M and N is the number of their activity actions. The big sim is computed as the equation 3. In summary, activity behavior similarity matrix is defined as equation 4. For computing activity sequence similarity, the time with adjacent time and similar activities is discretized into a time segment, and each segment is regarded as a weighted point. Thus, an individual's daily activities are described by two-dimensional representations of time and activities, and the comparison of two individuals' activity sequence becomes three-dimensional date comparison. An algorithm with the complexity of this is proposed on the basis of previous studies of longest common subsequence problem. Activity sequence similarity matrix is defined as equation 5. Finally, we aggregate the above two adjacency matrices to a composite matrix M as shown in equation 6. In our experiments, granularity of categories can be merged flexibly. We merge some categories and select appropriate weights omega 1 and omega 2 in equation 6, and K, that is the number of clusters by SC, CH score, and DB index. The parameters are set as following. From the overall trend with omega 1 increasing and omega 2 decreasing, the SC score has a trend of decreasing, CH score has a trend of decreasing, and DB index has a trend of increasing, which means that omega 2 plays a more important role than omega 1. So we select omega 1 to be 0.1 and omega 2 to be 0.9. Cluster result shows the best performance. It shows that clusters play better when K is smaller, but we hope to get more refined clusters that match the diversity of patterns. Therefore, we need to look for a trade-off. No matter what values omega 1 and omega 2 are taken, K is said to be 7, performs best, and evaluation. So we set K equal to 7. Figure 1 gives the activity time series of 7 clusters. One category corresponds to one color. X-axis is time from 4 a.m. to 4 a.m. in the next day, and the y-axis is the number of individuals. It can be seen that different clusters show obvious characteristics. 1. Personal care. 2. Socializing, relaxing, and leisure. 3. Work at night. 4. Household activity. 5. Work and work-related activities at day. 6 and 7. The main activities are eating and drinking, sports, exercise, recreation, religious, and spiritual activities, education, volunteer, travel, purchase of goods and services. Figure 2 shows PDF function of number of individuals by time. By statistical analysis, the typical activity characteristics of clusters are as follows. Cluster 1 has the largest proportion in personal care, about 900 minutes. Cluster 2 has the largest proportion in socializing, relaxing, and leisure, about 700 minutes. However, it takes up only 38 minutes to work. Class 3 has a third position in work and work-related activities with average 169 minutes, and the working hours are merely disputed at 0 a.m. Cluster 4 has the largest position in household activities with average 473 minutes. Cluster 5 has the largest position in work and work-related activities, about 534 minutes, and the working hours are merely distributed at day. Cluster 6 is the largest cluster with 23% of the individuals. Cluster 6 spends more time, and Cluster 7 spends the most time in eating, drinking, sports, exercise, recreation, religions, education, volunteer, travel, purchase of goods, and service. Based on activity behavior pattern mining, we further explore the features of social demographic information from the view of age, sex, race, labor force status, occupation, family income, number of the family, number of the underage children, time for work and family, having an enterprise, farmer or not, and education level. Table 1 is characteristics of activity behavior pattern and the social demographic pattern. We can say Cluster 1, they are middle-age group, low family income, low education level, the least time to work, so most of them in Cluster 1 is middle-aged unemployed people. In Cluster 2, we can say they are the oldest group, not labor force is the highest, low family income, so most of them are old people without labor force. Cluster 3, they are the youngest group. The working hours are merely distributed after 0 a.m. Most of them have low family income, higher proportion in service and related occupation. In Cluster 4, the largest proportion is household activities. They are middle-aged group, more female than male, so most of them are middle people doing housework. Cluster 5, the largest proportion is work-related activities. They are middle-aged group, more male than female, with a higher proportion of the white, high family income, so they are typical working people. Cluster 6. They are old age group, more female than male. Middle age income. They have more time in eating, sports, exercise, etc. So they are old middle age class people. In cluster 7, the most time is eating, sports, exercise, recreation, spiritual activities, etc. They are middle-aged group, more male than female. They have a high family income, so they are middle-aged rich people. Based on pattern mining, the pattern is recognized through social, demographic, or activity features by random forest. Fig 3 and Fig 4 are two test cases for pattern identification. The left of the finger is the input interface of pattern recognition. We input number of family, labor force status, relaxing time, film time, etc. The right of the figures is the output interface of pattern recognition. The test 1 is a typical working people, and the test case 2 is a typical housewife. We can see that largest probability that test case 1 is recognized to the pattern 5 is 0.7. Test case 2 is a typical housewife. We can see the largest probability that test case 2 is recognized to the pattern 4 is 0.5. In conclusion, this study contributes pattern mining and recognition by providing the linkage between activity behavior pattern and social demographic pattern based on the overall activity-based time use survey. Activity patterns are derived, providing vital characteristics of activity behavior and social demographics. The innovation is similarity computation between activity sequence for reducing the time complexity. In view of the large degree of discretization of the time segment, we use line segment tree and greedy algorithm to reduce the dimension, and the algorithm with the complex of this is proposed. Thank you. That's the end.